Hello, Year 10. So today we are moving on to another lesson, okay, and we've got another recording of me going through the PowerPoint for you. Same as always, we have a starter of some shape or description. Today is another one of our 5 questions. So I would like you to spend 5 minutes on these questions. Think back to our topic that we are on at the moment and maybe some other topics we have done previously this year. Give yourself 5 minutes to do this, so pause the video now and play it once those 5 minutes and your questions are complete. Here are the answers to the questions. Make sure to mark them and add in any questions you did not get correct. So today we are going on to particle motion, okay? So we're going to think about this in terms of each state of matter, but then we're going to think about how temperature affects the kinetic energy of particles, and then go into a little bit more detail about gases, okay, and how they have pressure. So moving to the start of this, we need to try and remember the arrangement and movement of particles in each state of matter. So on this diagram, you've got a solid, liquid, and gas. Okay, so what I want you to do is for each of these, write down what their position is. Okay, so what do they do? Are they fixed? Do they move over each other? Do they move around randomly? And then that movement as well, that comment. So say, okay, are they random? Is it regular? And then add in that detail. So if you want to draw the 3 states, absolutely fine, do so, and then underneath put it, or if you just want to do it in bullet points, so solid, liquid, gas, and then what you think those characteristics might be. Click play once you're ready to move on. So for a solid, we can see that they're in rows and they're packed closely together, okay? They are in fixed positions, and what they do is they vibrate on that fixed position. For liquids, they're packed closely together, but they're able to move over one another, okay? So they're not quite a regular pattern, but they are still quite close. And then gases, okay, so the particles are far apart and they move randomly in all directions. So these characteristics, we've gone over this table before, are really, really important for us to remember, okay? And if you make sure that you know what the changes of state are for each of these two. So thinking about when we've got a solid to a liquid, what is happening to the particles? What are they going to start doing? Okay, think about their bonds that they're going to break. They're going to change state, okay? Remember, it's that specific latent heat. That's how much energy is needed for a substance to change state. So that's where all of these parts of this topic are interlinking with each other, and they are very, very close to each other in terms of those links we can make. So thinking about this diagram, we want to think about, okay, which state of matter is the most dense and why, and then which state has the highest internal energy, and again, why is that the case? So give yourself a couple of minutes to answer these questions. These are 2 really cool points that we do need to make sure we know. And once you have done those 2 minutes of answering this, click play again and I will go through the answers for you. Okay, so if we're thinking about which state of matter is the most dense, those are going to be a solid, okay? So that'll give you your first mark for this question. The reason why they are the most dense is because the particles are packed very closely together. Remember, that's what our definition of density is how closely packed together the particles of a substance are. And solids are going to be more dense than liquids. And gases. Then we're thinking, okay, what state has the highest internal energy? That one is going to be gas, okay, or a gas. And the reason for that is because the particles are moving quickly in all directions. Okay, so that internal energy, the kinetic energy that those gas particles have, makes it have the highest internal energy of the 3 states of matter. Very important that we know those 2 key facts. So moving on a little bit from these, what I want us to do is answer these exam questions. So which one of these, X, Y, and Z, has the arrangement of particles in a liquid? And then which one has the particles of a gas? So it shouldn't take us very long to do, so I'm going to give you 5, 4, 3, 2, 1. Okay, so the particles of a liquid, that is going to be Z, so give yourself a mark, a tick for that one. And then which one of these has the arrangement of particles in a gas? That is going to be X. Some more exam questions for us to do. So drawing a ring around the correct answer in each box to complete the sentence. So in a gas, the particles are either vibrating in fixed positions, moving randomly or not moving. And then in a solid, the forces between the particles are something either stronger than, equal to, or weaker than the forces between the particles in a liquid. So again, I'm not going to give you too long for that. I'm going to give you about 20 seconds or so. Pause this now, click play when you're ready to move on. So the answer to B part I for this one is that their particles are moving randomly. Remember, gas particles, they're going to move randomly in all directions. And then part 2, in a solid, the forces between the particles are stronger than the forces between the particles in a liquid. The reason why they're stronger is because solids, okay, have them in their particles in very regular rows, very fixed shapes, okay, so the bonds, the forces between them are very strong. Whereas liquids, those bonds, okay, the forces aren't quite as strong, and that's why the particles can then move over each other. So going into a little bit more detail, you have on this slide 6 different key terms on the left. Then on the right, you've got the properties and reasons for 3 of those 6 possible key terms on the left. So what I want you to do is read through the properties and their reasons and try and distinguish whether you think any of the keywords would match up to them on the left. Once you have done that, I'd like you to write that key term and the property that you think and reason that you think it might match up to. So give yourself a few minutes to do this. Once you have finished, if you press play on the video, and I will go through the answers with you. Okay, so make sure that you have completed this task before you keep on watching. Okay, so here are the answers for this task. So you only needed to pick 3. They didn't need to pick any more than that. And you've got a solid, liquid, and gas. These are our 3 states of matter. So the solids, we know, have a fixed shape, but they can't flow, okay? So if you were to put, let's say, a block of wood into a beaker, okay, it would not flow like water, so it cannot flow. And you also have that they can't be compressed. They can be shaped, but they cannot be compressed, so you can't squash them. The reasons for these are that the particles can't move from place to place, that's why they're a fixed shape and they can't flow. And then the reason why they can't be compressed is because there aren't any spaces for the particles to move, okay, so they're all too close to each other. Liquids, okay, they can flow and take the shape of their container because the particles can move around each other, but they can't be compressed because, again, they are too close to each other and they don't have that space. Whereas if we're looking at a gas, okay, so they flow and completely fill their container, and that's because the particles can move in all directions, but they can be compressed, and that's because the particles are quite far apart from each other and have that space to be able to move into. Make sure you've got all of these reasons and the properties into your notes matched up to the correct state of matter. So if we have a look at this diagram here, you don't need to take any notes, you just have to listen to my description. You can see the cold temperature and a warm temperature. You will see on the cold temperature that the particles are closer to each other, whereas on the warm temperature, okay, so they're a bit further apart. The reason for this is that temperature can affect density, and if you remember, density means how closely packed together those particles are. If you've got a higher temperature, okay, you're going to have a lower density, and that's shown in the diagram because the particles are farther apart in the warmer temperature box. So if we're thinking about temperature, this also has another effect on kinetic energy. What I'd like you to do is just keep in your head what you think that effect might be. So now we're going to go into a little bit more detail about gases. Okay, so the particles of a gas are in constant random motion, okay, so that just means that they're going to constantly be moving randomly. And if the temperature is determined, this is basically determined, the temperature by the average kinetic energy of the particles. So the average energy of them moving about of all of the particles, that determines what the temperature is for that gas. But if you have a higher temperature, okay, you'll have more kinetic energy. And then as a result, you're going to get more collisions. So you'll see the diagrams on this slide that on the left, we've got a cooler gas, there's going to be less kinetic energy shown by the small arrows, and as a result, it's less likely for them to collide with each other. If we were to put all of you into an empty classroom, get you to walk around with blindfolds on, okay, and you were to walk very slowly, you wouldn't collide into each other very often. However, if we were to get you to start running around instead of walking very slowly, it is far more likely that you're going to collide with each other. And when particles collide with each other, that's when reactions can happen. And if we're thinking about those collisions, this links us really nicely to pressure of a gas. So when those particles of gas collide with the side of a container, they exert pressure. Okay, so if we're thinking about this, the higher the temperature, that means that the pressure of that gas is going to increase. And the reason for that is because the particles gain kinetic energy and collide with those walls of the container more often. So what I'd like you to do is to get down those 3 sentences that are in bold and those 2 diagrams into your notes. Once you have done that, there are a couple of videos on the next slide to watch, and then we have a couple of quizzes to finish the lesson. So you'll see on this slide, we have our 2 videos, okay? One of them is like a little practical demonstration. I'm not saying for you to do this at home, okay? It's just a nice little real world example of how pressure is affected. And then there's a little bit of more of an informative video is the link down the bottom. I will put these into the chat of the lesson if needed, if you can't quite get them to work from the lesson recording. So we've got a little quick quiz here now. So the first one is thinking about how does increasing the temperature affect the particles of a gas? And then the second, third, fourth, and fifth all think about how our gases and those little bits of information we've just been talking about for the past couple of minutes. So I'd like you to complete this quiz, okay, put your answers into your work, and I'll have a look over those when you send them to me at the end of the week. So to finish off your lesson, if you have completed this work before the hour is up, I will put a link to a carousel quiz at the end of the lesson. Make sure that you've completed all your work and you've saved it so it's ready to go over by myself when you send it to me with all of your work at the end of the week. I will look forward to seeing that work, everybody, and I hope you have a lovely rest of the evening and the week.